Welcome to SUSECON Digital 2022, and thank you for joining our session, Image-Based Operating System Deployments and Updates in SUSE Rancher.
In the next 25 minutes, we will present the motivation for image-based OS management and why we think it's a game changer. Rancher Engineering has developed a unique approach to unify operating system and container management within Kubernetes. This is accomplished by a new tooling which connects the operating system to Kubernetes. What we present is work in active development. At this point, we welcome all interested parties to get in contact with us. And about us, who are you listening to? So my name is Klaus Kämpf. I'm Senior Project Manager working in SUSE Rancher Engineering.
And I'm Andrew Gracey. I'm the Product Manager for Cloud Native Edge, working in the Edge business unit. So you likely heard in Basil's Edge keynote earlier this week about the solution stack that we are working on and our vision on improving the experience of running Kubernetes in a smaller distributed environments. The operating system functionality that we were talking to in this session is key to building out this vision in the Edge.
We believe our new approach of combining operating system and container management is a game changer. Let us explain why. Most of you should be familiar with the typical stack of the SUSE Linux and SUSE Kubernetes deployment in the data center or in the cloud. We will not go into details of the stack here. There are other presentations at SUSECON better suited to accomplish this. However, we want to point out two things. First, as you can see, Linux is still a separate building block from Kubernetes. In the diagram, the Linux layer is the green block in the middle and Kubernetes runs on top, shown by the blue block sitting on top. Second, we want to point out the infrastructure needed to manage the Linux stack. Here in the diagram on the right side, SUSE Manager is mentioned. This is a very useful tool for medium to large Linux deployments, but in this, once more. Second, we want to point out the infrastructure needed to manage the Linux stack here in the diagram. SUSE Manager is, Second, we want to point out the infrastructure needed to manage the Linux stack. Here in the diagram, SUSE Manager is mentioned. This is a very useful tool for medium to large Linux deployments. In a smaller setup, you will probably have RMT, the repository management tool, deployed.
And these are and these are really good solutions, but they do come with some trade-offs. The separation of the Linux and the Kubernetes layer does pose some challenges for operations and operating system management.
It starts with the domain separation, very often split into separate groups of certain administrators. Whenever the operating system management groups wants to deploy an urgent security fix, they need to coordinate their work with the container side of the house. And the Kubernetes administrator needs to ask a Linux group to deploy new nodes or decommission unused ones. That's a lot of coordination effort. That's a lot of crossing boundaries of the domains separation. And usually these teams don't get well together. So another point is the struggle for talent. The knowledge and operational procedures of Linux and Kubernetes administrators are different. And everybody knows how hard it is to get experienced administrators these days. And the Linux layer is built from packages, RPM files in SUSE Linux, which are hosted in repositories. The Kubernetes layer instead doesn't know about these artifacts. It understands container images hosted in registries. These are two types of infrastructure which need to be deployed and managed and secured. That's a lot of overhead.
Yeah, and with that security aspect, we introduced two wholly different operational and security models. Linux administrators love unified deployments, predefined stacks, and single operational set of procedures. And this often results in larger than necessary Linux stacks, prepared for more traditional workloads as well as Kubernetes. These larger stacks come with many packages that frequently have updates, more points of failure, and a larger attack surface. Um, also at the edge, we might not be as well connected, so updates might not be consistently applied across different locations, resulting in version skew across your environment. So, what if we could unify Linux and container management under one umbrella?
Now let's take a cloud native perspective to managing operating systems. First, there's a kettle versus pet analogy. Traditional Linux systems are often treated as pets, carefully configured to best support their workload. The cloud native approach instead doesn't care about individual systems. If one system doesn't behave, it'll be shut down and reimaged and brought back into the cluster. Ideally, this happens fully automated. Also in Kubernetes, the configuration data is not somewhere in the file system. It's stored in CRDs, custom resource definitions. There is simply no /etc file system to store configuration files in. Kubernetes also takes care to synchronize these resource definitions across the cluster. All cluster nodes will see the same configuration data. Resource definitions are typically managed by the kubectl command line tool or SUSE Rancher manager in a web browser. And updates should be painless. And updates are painless in Kubernetes because Kubernetes knows about the type of workload running in the cluster. And updates are handled without service interruption. It's a cluster. Updates are rolled out to a node, and other nodes take over this service while one node gets updated.
Lastly, since all of our workloads are container images managed by Kubernetes, there's no workload directly running on the operating system without the container layer in between. This means that we can have the Linux stack beneath Kubernetes can be very, very small. Also, because the cluster configuration is declarative, there are no admins logging into cluster nodes and running YAST or editing configuration files themselves. And everything can be, again, just as we had no version skew, we also uh, don't need to be worried about configuration skew because all of it's declarative and laid down by the central management plane. Um, and also, because we're distributing the operating system itself using all the same tooling and procedures as the workload, we get a chance to distribute and scan the operating system with the same tooling as the workload with tools like NuVector or Kubeboarding.
And this is how we envision management of the Linux operating system layer when we apply the cloud native approach to all layers of the stack.
So specifically at the edge, we do have some unique constraints that lead us to approach trade-offs differently than you would in a data center. Um, the first is the cost of an on-site visit. Typically in data center, you would have technical staff already there, ready to fix anything if it goes wrong, ready to onboard new servers as needed. But when you're talking about something at the edge, getting a technician to the same place as your hardware can be very costly. Between the travel time, cost of flights, having to staff enough people regionally, this can get very expensive and operationally time consuming. Uh, and this applies for both the initial setup as well as any future management or recovery. Um, we More globally, we want to reduce the risk of having to go on site to fix issues. Um, some of the locations that our customers are deploying to don't always have the best internet. Whether that's just because they've got a retail location that is only has dial-up still, or maybe they're installed in the middle of a field watching cows, which is a real example. We have to be okay with disruptions in the network at any time, with no expectations, at least from the product point of view, on timeline for reconnection or reestablishment of that good network again. Lastly, hardware can get expensive when you're both to purchase and to run. Uh, when we're talking about multiple thousands of sites, maybe multiple tens of thousands of sites, um, we need to be able to expect to run on middle of the road consumer grade hardware. And these tend to be something similar to like a Nook or a Raspberry Pi or something along those lines. And you rarely have data center features like baseboard management or IPMI type connectivity.
So for users of Kubernetes, the operating system is typically just overhead. This means that we should make it transparent to the user by integrating it better with the platform. We believe that we have a unique approach to make the operating system a first-class citizen within Kubernetes. And what we do is we make the operating system a container image. And as such, it can be managed like any other Kubernetes resource. This especially means that we now can unify the Linux and Kubernetes management. It's just one set of knowledge, one set of procedures executed by one group of administrators. No more coordination and domain separation. You will only need one container registry as the management infrastructure. No separate RPMs in RPM repository, because the registry holds your operating system and your workloads. All operating system management needs are handled through Kubernetes. kubectl on the command line or SUSE Rancher for the graphical user interface. Now, once again, last sector. All operating system management needs are handled through Kubernetes, be it via kubectl on the command line or SUSE Rancher for the graphical user interface. And this holds true for wherever your container stack runs. It's suitable for bare metal and edge deployments, as well as virtualized environments or the cloud. And this all is possible with a tool we have developed and we call the elemental. No, once again. This all is possible with a tool we have developed and we call elemental and its toolchain. So what is elemental? Elemental allows us to build the operating system layer in a container image. We are literally using a Docker file here. No more YAS, no more package selection. It's just usual Docker file everybody knows. Elemental does its work by a clever combination of existing Unix tools. Once again. Elemental does its work by a clever combination of existing Linux tools, like grub2 for bootloading, Dracut for the initial RAM disk setup, or systemd for system bring-up. And all these tools are already part of SUSE Linux Enterprise today. And this results in some quite interesting properties of the resulting operating system image. First of all, it's immutable, since the root file system is read-only. Second, updates are deployed in an A-B scheme. That means that there are always two copies of the operating system image on the system. One is the running image, and the other can be updated and changed meanwhile. And at the next reboot, we will switch both images. The freshly updated becomes the running image, and the other is available to receive updates. This also allows for bootloader assessment. That means if the new running image crashes or is misbehaving, we just fall back to the previous known good operating system image. And if in case everything goes bad, then we have a third image deployed on the system we call recovery image, from which we can restart and redeploy this AB scheme.
And this give uh, and this gives us a lot of additional confidence in our ability to update at the edge without needing to send somebody on site for potential failures.
And this setup also makes the system hardened, since every part of the running stack is containerized and configured in a declarative manner. There is no one logging in and changing etc files or running YAST or things like that. And bringing the operating system management task to the Kubernetes layer makes the stack also more manageable. There is no more coordination between two different admin groups and when to update and reboot a node. What is also important for us is a secure software chain. Our operating system images are signed and delivered in a secure software chain. That means that every step is testable and verifiable. Once again, that means every step in building the image is testable and verifiable. There's no man in the middle attack to change anything in the operating system layer.
Yeah, we're also looking at introducing secure device onboarding with the FIDO device onboarding spec, as well as doing some research around measured boot and secure boot in the longer term future.
So now that we have introduced this new tooling, we have also a new operating system stack specifically engineered for containerized workloads. And this is what we call SLE Micro for Rancher. SUSE is now introducing a new variant of the SUSE Linux Enterprise. Once again, SUSE is now introducing a new variant of SUSE Linux Enterprise called SLE Micro for Rancher. This is SUSE Linux Enterprise at its heart, but microfied for one specific purpose: running container workloads managed by Kubernetes. As such, it only contains packages absolutely required to start Kubernetes. And this is also a nice example of the joint work the SLE engineering and Rancher engineering groups are doing together.
So we hope we were able to whet your appetite for a drastic simplification of your Linux management stack and procedures. In case you want to know more, SUSECON offers you a couple more learning opportunities for this technology. We have a on screen. There are 4 different sessions that you might be interested in finding out more information about. So we've got a POV 1134, which is an introduction, overview, and roadmap. Um, we have the another tutorial around Edge. Are you ready? This is going to be a little bit more of a business view, but along with some technical pieces. Uh, 1211, the OS management at the edge with SUSE Rancher, will show much more of a deep dive into the how everything is hooked up and how to use the stack. And then lastly, the 1299, new ways to deploy and manage Linux. This session is going to show both SleeMicro and SleeMicro for Rancher, and kind of go into some of the trade-offs that you would get between the 2 different methodologies of using the stack. If you're interested in getting involved, probably the best place to start would be joining us on our user Slack. You can get there with it's rancher-users.slack.com. Should be able to get you an invite through that. And inside of that, there is a channel called Elemental. Um, we also, as you said, everything is open source. So on GitHub, inside of the Rancher Sandbox org, we have both the Elemental um, repo itself, as well as the Rancher node image repo with the Getting Started guide inside of that. Lastly, I wanted to give kind of a quick, like super quick roadmap of some of the things that we're going to be looking at next. Um, so we are currently in a stage of proof of concept. We've got a couple customers who are working with active proof of concepts at this time and rolling out this stack uh, to their environments. In the not too distant future, we will be looking at integration with Rancher Manager itself. This will come with a nicer user experience, as well as all the tools that you need to do higher level orchestration and automation. Um, then we're gonna turn around and start looking at compliance with the FDO or the FIDO device onboarding spec. We're going to be looking at scanning with NuVector, scanning the actual operating system images with NuVector so that you can do that scanning before you actually deploy a new update. Uh, and then lastly, we will be looking at some improved fleet integration. Obviously, all of these are subject to change and are fully forward-looking, but this is kind of what's on our mind at the moment. If you've got more, definitely let us know. Join us in Slack and start a conversation about what you would like to see. So, thank you for your time.